Anytime we solve a problem, we use tools, both physical and mental. In mathematics, we have a set of rules that create a structure with a surprising amount of flexibility. This allows us to shape expressions and later equations into the forms most useful for us. You can see our previous video for an introduction to algebraic identities and inverses, as well as the usefulness of zero and negative numbers. In this video, we are going to address 3 algebraic laws that allow us to manipulate expressions to our advantage. The 3 laws we are talking about today are the associative, commutative, and distributive properties of algebra. We associate with people that are in the same group as us. So, the associative property states that the grouping of numbers in a string of addition or multiplication will not change the result. For instance, the sum of 3 and 5 plus 2 has the same result as 3 plus the sum of 5 and 2. Likewise, the product of 3 and 4 times 2 has the same result as 3 times the product of 4 and 2. There is no change in the result, but the ability to choose which part of an expression to evaluate first allows us to maneuver a little bit more easily. Speaking of maneuvering, let's talk about the commutative property. When we commute, we move from one place to the next. The commutative property states that swapping the position of numbers in a string of addition or multiplication will not change the result. For instance, 3 plus 5 plus 2 has the same result as 3 plus 2 plus 5. Likewise, 3 times 4 times 2 has the same result as 2 times 3 times 4. With this rule, we can move terms to the most convenient position in an expression. But be careful and remember that whenever you move a term, if it has a negative, you have to take the negative with the term. Negatives are critical, especially in this next property, the distributive property. Now, when I distribute an assignment to the class, that means that everyone gets a copy of the assignment. The distributive property states that multiplying a sum will have the same result as multiplying each addend by the given multiplier, essentially handing out the multiplier to each addend. For instance, 3 times the sum of 5 and 2 has the same result as 3 times 5 plus 3 times 2. Likewise, 7x plus 2x is equivalent to x times the sum of 7 and 2. Remember, if the multiplier is negative, make sure that you distribute the negative with the multiplier. Now, distribution is sometimes called expanding an expression, while reversing distribution is called factoring. These 2 processes both play larger roles in evaluating expressions and solving equations. For example, we can use distribution to help us to more easily multiply larger numbers. Because 5 times 43 could also be written as 5 times the sum of 40 and 3, we can use the distributive property to simplify it. While I don't know 5 times 43 off the top of my head, I do know that 5 times 40 is 200 and 5 times 3 is 15. So, 5 times 43 is 200 plus 15, or 215. If we are multiplying 2 two-digit numbers, we can follow a similar process. 43 times 56 is equivalent to the sum of 40 and 3 times the sum of 50 and 6. We will start by treating the second sum as our multiplier. So distributing the second sum, we get 40 times the sum of 50 and 6 plus 3 times the sum of 50 and 6. If we use the distributive property again, this time distributing the 40 and the 3, the result is 40 times 50 plus 40 times 6 plus 3 times 50 plus 3 times 6. So we get 2,000 plus 240 plus 150 plus 18, which equals 2,408. Now, I know this can feel like a lot to remember, so that's why we've come up with the acronym FOIL to help summarize this process. FOIL stands for first, outer, inner, last, and tells us how to expand when we multiply 2 binomials. Multiplying the first term in each sum gave us 40 times 50. The outer terms gave us 40 times 6, the inner terms gave us 3 times 50, and the last terms gave us 3 times 6. This process works for multiplying any set of two binomials, or expressions with two terms. And it's especially helpful when the binomials contain variables. If we have the sum of x and 2 times the difference of x and 3, FOILing tells us that that is equal to x times x plus x times negative 3 plus 2 times x plus 2 times negative 3. This will simplify to x squared minus 1x minus 6. This will become very important as we start simplifying and solving polynomials. Today we covered the three laws of algebra, the associative, commutative, and distributive properties.